So, Mr. Walker wants to learn more about students' favorite lunch option, decide whether each method for selecting sample would be random and unbiased. Well, I mean, so random and unbiased. Explain your answer. Mr. Walker selects 3 students from each home roster and survey those students. This might be random, no, might be it's random and unbiased, right? Mr. Walker selects every student in the A line of the cafeteria and survey those students. No, because the A line might contain only kids from a particular class, so that's not. Mr. Walker uses the school director to select 10 students from each grade level. That's random, right? Because everybody has the same chance of being selected. That's okay. This one's okay. Mr. Walker places a survey in the school newspaper asking students to complete the survey. No, because the reason being, the kids who are interested only will be answering. So obviously they already have an opinion. So that would not be random and unbiased. Local reporter is doing something, doing a story in the community's response to new Walmart being built. Decide whether each conclusion is valid or not, and explain your answer. Right? So make the video too long, so let's just keep it to random and unbiased. The report surveyed 4 people at local gas stations. Concluded the majority of the residents are opposed to the new store, so obviously not random. Okay, the 4 people could be the 4 people in the same family who have the same views, so obviously not random and unbiased. The reporter surveyed every 50th person from the town's phone directory and concluded that 2 times as many people opposed the store that were in favor of it. So that could be random, right? Biased. The reporter surveyed 100 people at a rally protesting the store, obviously. Right away, that was not the one, right? Because they already are all protesting the store, so that would not be unbiased. The reporter surveyed every 3rd member of the city council and concluded that the town is evenly divided. Now, I don't think that would be unbiased because they are all part of the city council. Okay. The table below shows the amount of rain 2 cities received in a given month. Calculate the mean absolute deviation. Calculate the math for both sets of data, and what does the math tell us about city A and city B? So again, remember mean absolute deviation. We're talking about how far the data is away from the mean. So I think I need a calculator for this. Let's do city A. 15 plus 19 plus 12 plus 24 plus 0. Enter. This is 70. Mean, I'm going to write 70, and then we're going to divide that by 5. You're going to get 14. So, and then over here, I'm going to calculate the distance. Each of these values is away from 14. So 15 is 1 away from 14. 19 is 5 away. 12 is 2 away. 24 is 10 away. And 0 is 14 away. So we take that, right? The distances away from the mean. We add them up. And again, we divide that by 5. So now we have 6, 7, 8, 18, 32. 32 divided by 5 is 6.4. So that's the math for city A. Alright? City B, we add 6 plus 9 plus 11 plus 8 plus 9. We have 43. I divide that by 5, and you'll notice that the math would probably be a little smaller than that. So the mean is going to be 5. I'm going to round it to 5.4. Now we're going to measure the distance. Each of these points are away from 5.4. So 6 is 0.6. 9 is 3.6. 11 is 5.6. 8 is 2.6. And 9 is 3.6. So I'm going to add that and divide by 5. So notice that these numbers are obviously much closer to the mean. 0.6 plus 3.6 plus 5.6 plus 2.6 plus 2.7. Enter, we get 16. Divide that by 5. And our math's 3.2, right? So these numbers are much closer to the math, so basically more consistent, right? We had a question here. Which city would be more affected? Obviously, if the month of May was taken, obviously it would be city A, okay? Because that's very far away from me. 4. Okay, how much greater is the median salary of worker A than the median salary of worker B? Median salary of worker A is 175. Worker B is 150. Here's the median, right? There's the median, sorry. Worker B is 125, so let me erase that. So how much bigger? That would be 50. So that's the answer to number 1. What's the interquartile range for worker A? The interquartile for worker A is 200, right? Q3 minus Q1, which is 75. I'll write it over here. Worker B would be 175, right? Q3 minus 100, which is 75. So they're both the same. The size of the box is the same for both. What percent of worker B's weekly earnings fell between 75, here, 75, and 100? That'd be 25%. Remember, a box and whisker divides everything into quartiles, right? 25%, 25%, 25%, 25%. This is 25%. Between 100 and 175, between 100 and 175, right? It's from here. Let me shade from 100 to 175. That would be 50%. Right, 2 quartiles. What percent worker A's weekly earning fell between 100 and 200? So let's look at A. Between 100 right here and 200, which is right here, that would be 25, 50, 75. This whole thing here is 75%. And between 125 and 175, so between 125 and 175, this little, that's just 25%. 5. True or false? Okay. Group A's median is greater than Group B. False. Right. Here's the median for Group A. It's less than Group B. Group A's range is greater than Group B's range. Group A's range is from here. Remember, not interquartile range, just range, so the whole thing. Right. You can visually tell that Group A's range is bigger than Group B's range. So true. This is false. 75 for Group A's data fall between 76 and 81. 76 and 81, right? So we have 25%, 25%, 25%. So that is true. 25% Group B falls between 77 and 88. Between 77 and 80. No, that's not 25%. That's 25 and 25 here, so that would be 50. So that's false. The interquartile range is the same for both groups. Is the size of the box the same? So Group A, it's 78 to 81, and that's 3 units. Group B is 77 to 80, and that's 3 units away, right? This size here. Right? So Q3 minus Q1 for both, and they both get the answer 3, so that is true. 6. To determine whether Amy or Ed is the answer to the question. Who has the greater mean absolute deviation? Well, who's more spread out? Okay, just looking at this, you notice that Ed, his numbers are all a little bit more spread out than Amy. So Ed would have the bigger mean absolute deviation, right? Because their numbers are more spread out. Who has the greater median? Well, Amy, because here's her median. So this is Amy. Who has a lower extreme of 76? Well, the lower extreme of 76 is Amy. She has, right, her min value is 76. Who has the greater interquartile range? Just visually check who has the bigger box, right? That would be Ed. Zach's conducting a survey. Use the data to answer the given questions. Okay, so what is the survey about? what sports students in his school prefer. Okay. Basketball, the total population. So let's first find the total. 8 plus 8 plus 14 plus 6 plus 3 plus 1 plus 2. So the total is 34. So he asked 34 kids. What are for your favorite sports? 2 said tennis, 1 said volleyball, and so on and so on. So, how many students would you expect to select basketball? Well, 8 out of 34 selected basketball in his survey, so you multiply that by 850. Second one, so this would be the basketball. You guys can multiply that. How many would you expect to that would select what? Select football. How many would select football? Well, in his survey, 14 out of 34 selected football, so you multiply that by 850 again. And then baseball. In his survey, how many people said baseball was their favorite sport? 8 out of 34. So again, multiply that by 850, and that's how many you would expect out of 850 to like baseball. All right. Nine. What's the mean absolute? What's the mean absolute deviation for this data? Well, let's go through the whole thing. 6 plus 13 plus 6 plus 5 plus 10. So the total is, so the mean would be 40 divided by 5, which would be 8. So that's your mean. Mean absolute deviation, now you have to find the distance, right? The absolute distance that each of these points is away from 8. So 6 is 2 away from 8. 13 is 5 away from 8. 6 is 2 away from 8. 5 is 3 away from 8. And 10 is 2 away from 8. Alright, so we got to add those and divide by 5. So we got 2, 7, 9, 14. Divide that by 5. That gives us 2.8. That's our math. Right? It's not that bad because they are relatively close to 8. Okay, so Julie wants to, no idea, find out what music is most popular. She conducts a survey that is unbiased. Which of the following describes how Julie could collect her data? Placing an ad in a newspaper and asking students to reply to a survey? No. Okay, because in that case, everybody who likes, I don't know, let's say Taylor Swift, could decide to get together and answer the ad. Alright, so that would not make it unbiased. So no. By serving every fifth students in the band, chorus, and choir, also a no, because they have potentially a bias toward a certain type of music. By selecting every 20th student who enters the school. Okay, that's not that bad. Okay, so that would be random. And then by passing out surveys to the students and an on-the-road breakfast. Absolutely not. Right, you're asking all the nerds what kind of music they like. Probably have a bias. 10. Box and whisker plot shows the distribution of weight among dogs in 2 different pet stores. How much greater is the median weight of the dog in pet store 2? Well, in pet store 2, the median weight is this guy right here. That looks like 75. And the median weight in pet store 1 looks like 65. So how much greater is that? Well, 75 minus 65. 11. So a teacher randomly grades 5 students' homework assignment, and she finds that 2 of the students make mistakes. So 2 out of 5 that she randomly graded had mistakes. So 2 mistakes out of the 5 students. Now, if she were to grade 65 homework students, how many of those would she expect to have mistakes? Well, multiply that by 65. All right, so I can simplify that to 13, and about 26 of them she should, right, expect to have some type of mistake. Which inference is not correct? So look at the box and whisker. Which inference is not? 25% of 7th graders study for less than 16 hours a week. So that's 25% right here. This is another 25. This is another 25. And this is another 25. So can we say that 25% study less than 16 hours a week? Absolutely. That is true. 75% of the 7th grade study for less than 26 hours a week. So for less than 26 hours a week would be everybody from here, from that line down. Is that 75%? Yes. 7th grade students study for a median of 22 hours. Well, the median is this line right here. That's also true. And 50% of 7th graders study more than 16 hours. Wow. More than 16 hours would be everybody from here that way, right? So that's 25%, another 25%, another 25%. So that's false. I should have said 75%. Maria wants to know how many students in her school plan to attend the opening night. To best predict attendance, where should Maria pull a random sample of students to start? The official enrollment roster. Students waiting for the bus after school. In her theater practice, definitely not. In the computer lab school, definitely not. So I would definitely say here, the official enrollment roster. Right, unbiased. Table below shows the heights of basketball players. What is the mean absolute deviation? Oh my god, really? Alright, so let's do it. So again, add them up. 130 plus 162 plus 140 plus 178 plus 130 plus 142. Enter 882. So the mean, we add them all up, we get 882. And divided by 1, 2, 3, 4, 5, 6. We get 147. So here's your mean. 147 centimeters is the mean height. To calculate the MAD, we're going to find the distance that each of these heights are away from the mean. So the MAD. Alright, so how far is 130 to 147? It'd be 17. How far is 162 to 147? That would be 12 plus 3, 15. How far is 140 to 147? That's 7. How far is 178? That would be 28, 31. Wait, 28 plus 3, yes, 31. How far is 130 to 147? That would be 17. And how far is 142 to 147? 5. So let's add those distances and divide by 6. 17 plus 15 plus 7 plus 31 plus 17 plus 5. Enter. Divided by 5, so the MAD is 18.4. Quite a large MAD. So they're not really close to the mean. So the basketball team here, the heights, right? The height of the team, they're all over the place. So the mean, well, what does that also tell you? It also tells that you can't really trust this average too much, right? You can't really say that the average basketball player height is 147 centimeters, right? Because the MAD is so large, it means that the heights of the students are all over the place. They're not really close to 147. 15. All right. Mean absolute deviation for the girls' data is greater than the boys. No. Look, the girls are. If you look at the girls, they're a little bit closer together, right? Their values. The boys, what is this? The minutes, right, are more spread out than the girls. Okay, so if we had all the numbers, right, we actually had all the numbers, you would see that the boys had a bigger spread. Okay, so this is false. The mean absolute deviation for the boys' data is greater. For the boys is greater. That's true. Just talk about. The median time for the boys is greater. Not true. That's false. But the median of the boys is here, and the median of the girls is here. The interquartile range for the girls is greater. No. Look at the box. Look at the size of the box of the girls. Definitely smaller. So that's false. All of the above are true. Box and Whisker, what score did students have to get in order to receive the test? Wait a second. So I started to give the students this test scores in the top 25% a treat a class of treat. So anybody in the top 25% of these, right? Anybody who got from here to here will get a treat. What score do students have to get in order to receive the test? Well, greater than 80%. Yeah. 17. All right, so again, it was a survey. We asked 75 people. Here are the results, where they're going to travel, or how they're going to travel, actually. If there are 480 students, how many should we expect to be traveling by plane? Well, traveling by plane was 10 out of the 75 people surveyed. Multiply that by 480, you get, whatever is it, that is 10 over 75 times 480 equals 64. So we should expect about 64 students out of 480 to be traveling by that. 18, Box and Whisker. Distance in miles that students live away from school. Let's answer the questions. What is the median distance? Well, the median distance, that's easy. Right here, it's 9. What's the interquartile range? Well, it's 13. Q3 minus Q1. 13 minus 5 is 8. So here we go. What percent of students live 5 or more miles from school? Well, anybody who lives 5 or more miles away from school would be from here that way. So this 25%, this 25%, and this 25%. So 75% of the students live 5 or more miles away. 19. Here's the first 3 scores. What does she need to get her average of a 92? What she need to take on her last last quiz to get her average to be a 90. Alright, so many ways you can do this. So right now you know that 85. So mean, right? To find a mean, we add all her grades. We don't know her last grade here. We're going to divide that by 4, and that gives us 90. So that's what the question is saying. Alright. So we can combine like terms. We go 88 plus 93 plus 88. Let's rewrite these 3 numbers as 269 plus x over 4 equals 9. Right, so do your thing now. Over 1, cross multiply, so we get 269 plus x, cross multiply 90 times 4, we get 360. Subtract 269 from both sides. And x, which represents her what do you call it, our test grade, quiz grade, the last quiz grade should be 90. So in order for her to get a 90 average, she needs to get a 90 on her last quiz. 20. Okay, so Box and Whisker, 2 algebra class scores. The range for class 1 is larger than the range in class 2. That's not true. Look, the range, not interquartile range. The range for class 1 goes from here to here. The range for class 2 goes from here all the way to here. So, false. The median from class 1 is larger. Yes. Look, here's the median for class 1. Here's the median for class 2. Class 1 is definitely greater. The mean absolute deviation for class 1 is greater. No. Well, if you had all the data, right? If you had all the scores, class 1, look, they're all a little bit closer together, and class 2, our data is more spread out. So class 2 would have the greater math. So this is false. The interquartile range for class 1 is greater. Well, also no. Well, if you look at class 1, look at the size of this box. That's the IQR, right? The size. IQR for class 2 is definitely greater, so this is also false. How much greater is the median for worker A than for worker B? All right. So worker A, the median is this value here, which is 175. Worker B is 125, so it's 50 greater. I think we did this question. Has got to earn the following scores. Which of these scores will be affected if he earns a score of 50? All right, so think about it, right? 73 plus 86 plus 91 plus 87 plus 88 plus 79 plus 82, and then he takes a 50 on the last one. So which will be affected? It would be the mean. Would the median be affected? No, because the median, remember, if you put this in order, right, 50 here, what's the highest one? 90. And when you work towards the middle, right, to find your median, will the 50 affect it? No, because it gets crossed out right away. So the only one would be letter C. 23. Again, what's the score he needs to take? Average what's the mean score he needs to get on the exam? Toward the final grade. What the heck? Oh, it's a tricky question because here it says that his average is in the homework category is 93, right? So 93% of 20. So 93% of the 20 points. 20. Second one, he has 92% of the 20 points available. That's 30 minus 35. Sorry, let me take that back. Try to understand the question. I'll get back to you guys on this question. That's okay. 92, 20. Alright, so let's do 0.93 times 20. That means that out of the 20 points, he has 18.6. Let's do 0.92 times 20. That means that here he has 18.4. And then here, 35 out of 40, 35 out of 40 is that he has 87.5. So right now, his 18.6 plus 18.4 plus sorry, this one actually is just 35. It's 35 plus something over here, right? Call it x. Divide that by 4 should give his average of. Now, I'll get back to this. 24. What is the difference between the median of a turkey sandwich and the median for the ham sandwiches? Turkey, let's put them in order. 7, 8, 12, 13, 15. So the median, we call this turkey. The median is 12. For the ham, 6, 8, 9, 11, 16. Ham, the median is 9. So the median is, the difference in the median is 3. 25. Emily wants to know the favorite food of middle school students. Which activity will give Emily the best information? She surveys every student in her math class. No, because it's biased, right? Doesn't represent the whole school. She asks all the teachers at her school. No, she wants to survey students, so that's no. She observes the students in her school cafeteria for a week. No, because that means they are eating cafeteria food. Wait, actually. She observes the students in her school cafeteria for a week. She surveys every 10 students leaving her school cafeteria. This is probably the best, right? Because I don't know who she's observing and when she's observing. So if she observes only the 6th grade or only period 4, only period 5, unless she stays there for the whole 4 periods of lunch, that'd be a different story. But this is probably the best one. She surveys every 10th student leaving her school cafeteria. Thinking of looking around. Here is the name of the book that I'll never get to finish. And that's The Emperor of All Knowledge. That's your bonus. Okay? Good book. Just never get to finish. 27. Box and whisker plot. What is the range of the data? Well, the range, the interquartile range is 95 minus 17. So that would obviously be 7. That other question is bothering me. 28. Box and whisker. There's no question here. Show, blah, 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 blah. We're missing a question. 38 to 54. That's quartile 1. 38 to 81. That's 75%. And then 54 to 54 to 72 is 25%. I don't know what the question is asking. That's 25% of our data. 38, which is here, to 81, which is here, that's 75% of the data. 38 to 54, from here to here, is 25% of the data. Asking. And then the last one, 54, which is from here to 81, is our box. And that's 50% of our data. 29. The range of number of students in each class is 13. Okay, the median number of students in each class is 9. Which of the following box plots could represent the number of students in the classes? The range is 9. So which of these have a range of 9? So this one has, it's not A, because the range is 19 minus 6, which is 13. That's not it. The median is 9, which is there anything that has, well, this one, let's see, this is about 21 minus So the median number of students in each class is 9. So which one has a median? This one has a median of 9. Is the range 13? Well, we have 21 minus 3. The range here is 18. So this doesn't look like it is. 18 minus 9 is that. And the median here is 13. So that's not what. That's not it either. The median here is 13, and the range is 22 minus 9, which is 13. So that's also doesn't work. What the heck? The range of the number of students in each class is 13. But anything with a range of 13? Well, actually the first one, I'm sorry. What am I looking at? So here is 19 minus 6. So 19 minus 6, this value here, and this value here. 19 minus 6 is 13. So that is the range. Check. The median is 9. Right here. Check. So actually, sorry. It is 30. Which statement is what do you call supported? Sunnyvale has the lowest noon temperature. Noon temperatures for 2 cities were collected over a period of 1 month. Okay, so Sunnyvale has the lowest noon temperature. Is that true? Well, no. Well, which one's Sunnyvale first of all? Sunnyvale is the one on the left. Sunnyvale, the low noon temperature belongs to this city, which is called Marytown. So Sunnyvale versus Marytown. Okay, so right here, Sunny and Mary. Mary has the lowest temperature. So the first one is false. Marytown has a greater interquartile range. Well, does it? If you just look visually, does Marytown have the bigger box? Yes, it does. So that's true. The median temperature is the same for both towns. Well, here's the median for Mary, and here's the median for Sunny. So obviously, false. Marytown has a greater range of noon temperatures. Well, the range for Marytown is whatever this is: 55, 56, 57, 58. Well, this is 58 to 70. So you take 70 minus 58. That gives you 12 for Mary. For Sunnyvale, the low temperature looks like 59, and the high temperature looks like 70, 71, 70, 72, which is 13. And Marytown has a greater range now, so that's false. Alright. Oh, that's it. Yeah, not that bad. Except for this question, which I will, number 23, get back to you on that. Too much of your valuable time. Alright, that's it.